Welcome to solverfy.
Okay, so in this problem, we have to find out the empirical formula of some compounds, and we are given in first part of this problem, or in part A of this problem, we are given the number of moles of the elements which uh, composes the compound, and from here we have to find out the empirical formula of the compound. So if we are given number of moles of each element, what we have to do is first we have to divide each number of moles by the smallest number of mole present here, and then those values we have to um, make it to the nearest whole number, and that will be the ratio of each element present in the compound, and from that ratio we can find out the empirical formula of the compound. So here we can see that the smallest value is 0.052, so we will divide all of the number of moles by the 0.052, and which will give us the ratio of the elements. So the ratio of K, or the potassium here, will be 0.104 mole over this 0.052 mole, and this will give us a value of 2. And then the ratio of carbon will be 0.052 over 0.052, which will be eventually 1. And then the ratio of oxygen will be 0.156 mole over 0.052 mole, and this will give us a value of 3. So that means the ratio of KCO is 2 is to 1 is to 3, and that therefore we can write the empirical formula of the compound as, since we have 2K, we can write K2, we have 1C, then we K2C, and then we have 3 oxygen, we will write O3. So this is the empirical formula of the compound, which is K2CO3. Then in the part B of this problem, we are given the mass of um, the elements which makes up the compound. So what we'll have to do first, we'll have to find out the number of moles for each element, as we know that the number of moles is equal to mass over molar mass. So we'll divide these masses by their molar masses to get the number of moles of each element, and from then we'll just follow the procedure we did in the previous problem. So let's find out the number of moles for each element first. So moles of Sn or tin will be mass of this, which is 5.28 gram, over its molar mass, which is 118.7 gram per mole. It will give us a value of 0.044 mole. So for best accuracy, what is done here is, for the molar mass, 4 significant figures are taken as the molar mass of each element. So the number of moles of tin is 0.044 mole, which we have calculated here. Then we'll calculate the moles of fluorine, which will be the mass of fluorine 3.37 gram over its molar mass, which is 18.99 gram per mole, and this will give us a value of 0.177 mole. Now we have the number of moles of both the elements present in the compound. Now again we have to divide this number of moles by the smallest value. So from here you can see that the smallest value is 0.044. So we will divide these two number of moles by 0.044 to find out the ratio of tin and fluorine in this compound. So what we will do is, so the ratio of tin will be equal to its number of moles, which is 0.044 by 0.044, and it will give us a value of 1. And then the ratio of fluorine will be 0.177 mole, which is the number of moles of fluorine we calculated, over this 0.044 mole, and this will give us a value of 4.02. And since it's very close to 4, we can write it 4. So the ratio of Sn and F here is 1 is to 4. That means the empirical formula will be, since we have 1 Sn, we write Sn, and we have 4 fluorine, and 4 will go as a subscript of 4 F. So the empirical formula for this compound is SnF4. Now the next part of this problem, we have to find out the empirical formula of a compound which has 87.5% of nitrogen and 12.5% of hydrogen. So when we are given percentage of the elements, what we'll do first is we'll sum up the percentage to make sure that the total is 100% and there is no other element present in the compound. So 87.5% plus 12.5% is easily we can see that its total is 100%. That means in this compound only nitrogen and hydrogen are present and no other elements is present there. Now what we have to do is, when percentage are given, we will assume that the total mass of the sample of this compound is 100 gram. That means this 87.5% will turn into 87.5 gram, and 12.5% will turn into 12.5 gram. And then again we will just find out the number of moles for each element, and then we will divide those number of moles by the smallest value, and from there we will find out the ratio of the elements. So let's find out the number of moles for it. So moles of nitrogen here is 87.5 gram, which is the mass of nitrogen in the sample, over nitrogen's molar mass, which is 14.00, and this is in gram per mole. So this will give us a value of 6.25 mole. So this is the number of moles of nitrogen. Now we will find the number of moles of hydrogen. So mass of hydrogen is 12.5 gram, and molar mass of hydrogen is 1.008 gram per mole. This will give us a value of 12.40 mole. So this is the number of moles of hydrogen. Now we have to divide the number of moles by the smallest value, and the smallest value is 6.25. That means the ratio of nitrogen will be 6.25 mole divided by 6.25 mole give us a value of 1, and the ratio of hydrogen will be 12.40 mole over 6.25 mole give us a value of 1.98, and since it's close to 2 we can write it as 2. So the ratio of nitrogen and hydrogen in this compound is 1 is to 2, and that means the empirical formula is NH2. So this is the empirical formula for the compound.